Hi, everyone. My name is Frances Kweller, and I'm so happy that we're doing this right now. Thank you all for being here. Without further ado, we have William Billich, who is the author of Kweller Preps AP Physics Level 1 book. He handwrote every single page of the book, line by line. And we're really excited because before we start, he's going to go through his credentials, and we can't wait to hear. William, take it over.
All right. So hello, everybody. So I have been in the fields as a college student. I studied electrical engineering first, then switched to physics, did an internship with the Department of Defense for a little bit, found out that I was helping to develop infrared imaging for semiconductors, specifically the physics we did. It's called molecular beam epitaxy. Doesn't matter, but I wanted to get to more biological things. I also didn't want to do, a lot of it was military subcontracting. So I'm like, I want to go into medicine instead. So I graduated with a degree in kinesiology and a minors in neuroscience. Before getting, I did about 4 or 5 years of biomedical research. I have a couple publications in biomedicine. In particular, I was interested in how I've always heard weightlifters would swear by, you don't take anti-inflammatory drugs. You don't take aspirin or Advil or anything like that because it slightly inhibits muscle growth. So I did a research study based off that, amongst a couple other things. Then I went to medical school. And then after I did all that, I decided that I was going to become an orthopedic surgeon. And I just decided I kind of like education more so. So I left that behind, have started tutoring for a bit. Now I'm kind of running my own educational company. I really enjoy it. So I do a lot of homeschool programming. And like right now in particular, I teach math, science, programming, and I'm also teaching a lot of like coding and robotics, just because I haven't learned it yet, might as well. So one of the things that happens when you study multiple fields of science is you kind of get a sense, okay, this is how this field thinks, and this is how this field thinks. And when you could juxtapose how different fields work, you kind of get a sense of contrast, right? Oh, this is how, like, pre-meds in particular have a particular skill set they develop. They become very good at memorizing gobs of data, right? And that's what medicine is. Medicine is just memorizing massive quantities of information. Physics, you memorize very little, but you're able to think along a track for a very long time. So when you do these multiple fields, you just get a sense of how they all work a little bit. And that's a lot of where I'm coming from. I wrote this book in particular because after hopping around different fields and doing things like the MCAT, et cetera, I wasn't too happy with how the test prep for this exam in particular worked, because a lot of it was like simple, like fill in the blank answers, et cetera. And most people don't need that. What they need help on is help on the free response questions. This is what gives people the most trouble. So let me say this outright. If there's any one stupid take-home lesson you could take from this, so hopefully there's many, but it's this top one. Plain and simple, do old AP exams. Go on the college board, do old AP exams. And there's a very particular way in which I mean this. And there's active learning versus passive learning. So passive learning is, it's very easy to look at the old exams, watch the, look up the answers because those are available too, and be like, oh, that makes sense, that makes sense, that makes sense. It is entirely a different thing to produce those answers on your own. You have to try your best to answer those things completely on your own. Then refer only when stuck. And this is the entire premise upon which I wrote my book. It's always like, well, let me just give you this little bit of hint to help you to the next part. And then slowly you start learning how the game works. And you all might be aware that the AP Physics 1 has the lowest pass rate of any exam. And I think, again, the number one reason is people are studying for it incorrectly. I don't think the material is that hard. It's just they're not using the proper study techniques. And honestly, all you have to do is study for the free response questions, because if you get those down, the rest is easy. One more thing that I think the AP exam does that people aren't used to is a lot of their problems are synthesis problems, which means you will be doing a problem that involves kinematics and forces and maybe energy and rotation all at once. And so we're so good at solving a problem in a particular compartment. But when you combine those compartments, you get kind of stuck because we're just not used to it. So that's a goal that I have for at least, I think in an hour, we can at least accomplish a little bit about this today. Less important, by the way, after you do that, is do content review of particular topics. So like projectile motion, forces, energy. It should be in like a one-page understanding in your head, so to say. And by the way, if you have any questions after this, you can email me at info@kwellerprep.com and I can contact you there. But without further ado, let's go into it. So the way I want to do this now, and if somebody could shoot just some texts on here, just so I can have a sense of where your timing's at, you can let me know, hey, I'm done with this part, is I want to practice how I would ask you to study for the exam by using problems that come directly from my book. So here's the first one. This is not from an old AP exam. This is one I wrote myself to mimic it. And I want everybody, it's going to start off simple, but then it's going to get kind of difficult. By the way, let me add one more thing. You're probably aware that there are very few, in fact, there's only one problem in the last 6 years of the AP exams on the free response questions that had a numeric calculation. Think about that. That means you got to be very good at deriving things in terms of variables. That's super important you get used to that because a lot of us are used to plug and chug. It's different when you're working with variables. So everybody take a look at part A. This one's relatively straightforward. I'm going to pause my screen, give you all a time to think. Please try to do this yourself. It'll be so much more helpful. And pausing, go for it. I'll give us about 2 minutes. And if somebody can, please, in the chat window, either to me or to everybody, let me know when you have completed part A. And this one's decently straightforward. And Francis, by the way, there's somebody in the waiting room. Do I let them in as well, or I'll shoot you a text? I'll give 1 more minute. And maybe you need more time. Somebody tell me if you need more time too. I have no sense of where anybody's at with this. So I'll want to connect with you all a little more to feel where you're at. All right. Does anybody have an answer? Would you like me to proceed? Somebody, anything. If not, I'll just fly blind and then just start filling in the blanks for folks. But okay, so the purpose of this problem is there's a common theme on the AP exams, especially kinematics, is they love that they love to ask in so many different ways this difference between horizontal and vertical components, right? And you always keep them separate, right? What happens in the X direction is independent of what happens in the Y direction. And so I created a problem intentionally just to try to throw folks off that has a horizontal acceleration. Of course, it has a vertical as well, but the rockets boost it purely in the horizontal direction. So this is a little bit different. So part A is calculate the average horizontal acceleration of the rocket during the first second. Now, whenever you're kinematics, basically you only need 3 equations off the top of your head. And I've kind of phrased them in my own way. And this is very similar to how the AP exam phrases them. But V final equals V naught plus AT, V final squared equals V naught squared plus 2A, blah, blah, blah. You can see these 3 equations here. But these are your standard 3 equations. They're the only things you really need for kinematics. Everything else you could figure out on the basis of these. So when you have one of these standard plug and chugs, you ask yourself, maybe your teachers have gone over this, like, what are your givens? Well, we know the time is 1 second. We know that the final velocity it attains is 30 seconds. It begins at 0, ends at 30. And so, yes, we have it that it's at a height of 13 meters, but that's not relevant to this first part. So all we would do is just a simple, an acceleration calculation, just use the definition of acceleration. V final minus V initial over time, right? And I plug in, V final was 30, V initial was 0, time was 1 second. And I hurried up the calculation just to, run this efficiently. So the acceleration is 30 meters per second squared during the first second. So during the first second, this rocket accelerates to, 30 meters per second squared. All right. Part B, so that's going to start easy. They're going to get progressively more difficult. Take a look at part B to the best of your ability. Attempt it, and anybody can shoot me a text in the chat window with a question, etc. And so Andrew looks like, oh, and by the way, my screen was frozen when I showed the calculation here. This is the V final equals V naught plus AT, plugged in 30 meters per second squared is the acceleration. Okay, part B. All right, resuming window share. So this next part says, when the engines first stop firing, so the rocket accelerates for 1 second horizontally off the cliff. And then it does that, it'll continue to fire its horizontal boosters for 1 second, and then it stops. But now the question is, what height is the rocket at? So again, this is trying to take advantage of the fact that there's this common theme in physics where, like, we don't care what happens in one direction if it's orthogonal to the other. They don't have anything to do with one another. So it doesn't matter that it has a constant velocity or no velocity or an acceleration, blah, 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 in the x direction. You could treat this rocket as if it was just an object dropped straight from a 13-meter high elevation for 1 second, right? You could use that to calculate the height. It has nothing to do with the acceleration, right? So anywho, you would identify, okay, the second equation is the most appropriate fit for this. You're trying to figure out D final here. Begins at a height of 13, initial velocity is 0, so that crosses out. And by the way, you're allowed to use -10 on the AP exam. They will grade you just the same. So you can stick with 9.8 if that makes you happy, but you don't have to. They're not going to grade you. They're not going to give you any more or less points. So I'd say stick with 10. It's easier. Makes your life easier in the calculations. And so just skipped a little step of the algebra. But now we find out that, okay, it'll be at a height of 8 meters after 1 second elapse. Again, it has no bearing on the fact that it accelerated horizontally. Okay, next one. This one will take a little more thought. Calculate both the final, I'll zoom a little better. Calculate both the final vertical and horizontal velocity of the rocket the moment before it hits the ground. Oh, sorry about that. And pausing. And to be clear, I mean that's separate, the horizontal component and the vertical component. Thank you, Xavier. The height was 8 meters, by the way. Thank you for asking. 8 meters. And if you have follow-up questions, feel free to text. Yeah, no problem. You're welcome. I'm glad, it's hard for me to know where you all are at. You know what I mean? So that's why I like the text. I have no idea what your time is. And unfortunately, I have to hurry you a little bit to cram everything in. Okay, so part C again. I'll resume. And by the way, let me know if there's anything I'm going to mess up. I'm going to forget to unfreeze my screen like I just did it earlier. But so this one, this should be 30. So the trick is, first of all, with the horizontal, right? Because there's two components here, the horizontal and vertical. It attains a final horizontal velocity of 30 meters per second. So of course, it will continue with that same velocity until the moment before it hits the ground, right? That's never going to change. So if it's 30 meters per second here, well, it's still going to be 30 meters per second the moment before it hits the ground. So again, I'm just redisguising that same, horizontal and vertical components are perpendicular to one another in another form. And again, I keep saying this, but like this trick will show up on your exam. I guarantee it in some way, shape, and form. They will try to see if you're clear on this. So in any event, that was easy. The horizontal component is just 30. Now for the vertical, well, decently straightforward. You just treat it again as if it's an object that's dropped from 13 meters in the air. And so, you identify which equation is the best one to use here. I use the second one again. Simple algebra plugs in. However, one little thing is, remember, they're asking for horizontal and vertical components. So make sure I would take the square root. This would be a positive number. I think the square root of 260. But, obviously you can't have, when you take a square root, you can't get a negative number. You have to slap on a negative at the end, plus or minus, right? So you slap on a negative at the end to indicate that it is downward. This is easily worth 1 point. a thing that you could miss. Again, if they actually ask you something that is based off of a numeric calculation, and they rarely do, but you do need to understand this. So again, we indicate direction with the sign. Okay, that's easier. Oh, thank you for asking. Where the AP exam employs this trick where the answer is in the question. No, not really, by the way. I'm sorry if I'm unclear about that. What I mean by the trick is that the trick is this concept. Like the AP exam loves recycling the concept that vertical and horizontal components are orthogonal. And they'll ask you that in multiple ways. But no, the AP exam it's not like reading a passage reading thing where if you just read it carefully, you can derive the answer. No, it's not like that at all. You have to come in with good background knowledge to these problems. Otherwise, you will not do well. Again, hence the only 50% pass rate. Just be practiced on these. Okay, D is a little tricky. Feel free for anybody to ask me questions as we do it. Again, I'm going to do this a little too fast, but it's just for me trying to cram everything in here. This one's a little tricky. So calculate the total horizontal distance the rocket travels before it hits the ground. I rather like this problem. You'll see why in a second. And pause my screen again. And anybody else, some folks have been texting me, other people can in the meantime while I'm explaining other things. Like if you have another question about another topic on the AP exam, ask me it while we're waiting. That's no problem. And I will address a very common misconception I see when students I have tutored have answered this question. Okay, again, sorry if I did not give you enough time, but let me just go over the conceptual understanding more so than the mathematics. You notice my illustration of the mathematics is very minimal because I assume y'all are in AP physics, you can handle this. You know, you can handle the algebra. What will trip you up is the tricks. Close, okay, close, Xavier. So let's look at this. Again, there's a reason why I like this problem. So the thing to understand is because I did ask for, calculate the total horizontal distance it travels. So I think I know what you did, by the way. Consider this rocket as if it went through two separate segments. The first segment is, it is accelerating, right? From time t equals 0 to time t equals 1, this rocket is, boosting horizontally. Should be kind of hard to illustrate this because we typically draw a parabola, but this is a parabola that also has an object accelerating. And the x direction, I'd have to think about that for a little bit. It'd be, I don't know what type of shape that would be, but in any event, it'd be parabolic, something-ish. Now, so it looks something like this, but during that interval, it's accelerating horizontally, right? And then after that, after the booster is cut off, now it is coasting for the latter half. And I'm guessing you calculated the latter half. So segment one again is, hey, the rocket's traveling with a constant acceleration. So, let me line this up. That bothers me that it's not lined up nice. There we go. That's better. Okay. So segment one, it's traveling with a constant acceleration. I just plug in. We're trying to figure out the distance it travels. Begins at zero velocity initially. And then we know the acceleration was 30. So travels 15 meters during the first segment. During the second segment, it's got a constant velocity. So we could just use, velocity as distance over time. Or if you arrange it, distance is equal to velocity times time. But here's the problem. We need the time that it is coasting for. So in order to figure that out, let's figure out first the total time it takes to fall. So it takes, begins at a height of 13 meters. So again, I'm using same theme again, vertical and horizontal orthogonal. I'm using the same trick again. I'm saying, all right, let me just figure out the time it takes for me to drop an object 13 meters. And that will be useful in figuring out how long this thing is traveling horizontally. They will be the same time. They must be. So I do some simple plug-in and I find that the total time is 1.6 seconds. Now that I know the total time, I would subtract the time during the first segment, which is 1 second, to find out that the time that the thing is falling or coasting for is 0.6 seconds. Now that I know it's 0.6, I go 0.6 times 30 and I get 18. And I'm guessing that's where you got your answer from, right? That's my guess anyway, because it'd be, you did that quick too. But anyway, all you have to do is add the two segments together. So now 18 meters while it's coasting, 15 meters while it's accelerating, total distance, 33 meters. Add the two segments together. This last one's going to be a little rough. So even if you don't have time to do the full algebra, I hope you can pull back some themes from this. And the cool thing is, even in an hour session, what you can derive from me is some themes and strategies to go about. Like maybe you could adjust your studying style accordingly. Because I've worked with many students through this. Part of the reason I wrote this book initially is I was tutoring one kid who later went to Stanford, absolute mathematical genius, was better at math than I was. Like by far, even though he's only in high school, I'm like, oh my God, this kid's brilliant. But I helped him with the AP exam and I was like, oh, this kid's tanking on these questions. This is unfortunate. And it's simply because his teacher never prepared them for them. He's never seen anything like these. He always did these plug and chug things that came from the text. So part of the reason I wrote this book was like, oh, let me help him adjust his strategy so he's ready for this, because he's clearly intelligent enough. All right, take a look at part E. This one's difficult. Well, it is and it isn't. There's a kind of a shortcut way, but I'm going to show you the long way just in case. Now, again, I'll give a minute or two more. Hello, whoever just joined us. We are doing, you won't have enough time to go through it, but we are doing part E of this question. And to be clear, this is not a question that has shown up on the AP exam. This is one I wrote myself to mimic the AP exam.
And William, I'm, in and out, but I just want to let everyone know, don't be shy. This is your opportunity. If you want to type a question into the chat box. So to the best of your ability, be interactive. If you have a question, don't hesitate to ask. William's more than happy to respond. Okay.
Thank you.
Keep going.
Yeah, absolutely. Like I have kind of a general format I wish to deliver to you all, but I don't mind adjusting per your needs. I have no problem with that. And so to the new person, we're doing, again, part E of this one, which you probably won't have enough time to attempt. Just follow along. All right, so now I've seen something like this on the exam prior, hence I wrote a question to mimic it. So you have the same experimental setup, but you launch the rocket on planet X, which has half the gravity of Earth. By what factor will the time the rocket takes to hit the ground change? Illustrate the answer using equations. So again, same little trick. It's not like the fact that this thing boosts horizontally is irrelevant. What matters is you have one object and you are dropping it, on planet Earth, and another object and you're dropping it on planet X, which has half the gravity of Earth. So by what factor will the time change? Now, there is a shortcut to this, but the shortcut's only useful if you get the math behind the shortcut. So let me just show you this. And it's kind of a bit, we'll give you the notes after if this is a bit overwhelming, but you do need to know to do something like this because there's derivations on the AP exam that are harder than this for sure. So here's something I say. So again, something you could leave today's session with is themes. If you're stuck and you have no idea what to do, I always say, my book always says the same thing. Step one is understand the problem. And I think, I kid you not, it sounds so simple, but what people will do is they immediately just start, because they're like, I don't have any time. So they just start solving something new. Step one is like, okay, what's going on here? And you say, oh, okay, I'm dropping one object on Earth, one object on planet X. It's got half the gravity of Earth. Okay, now that you've kind of understood it, now represent that with equations. And so you would say, all right, well, I know it's one of these kinematics things, so I could use, I'm trying to compare, I need an equation with time and acceleration. So notice, by the way, this equation would also not be useful because there's no time in it. So you would say, okay, this equation is not useful. This equation is not useful. I got to do something with this. And then after you jot down a relevant equation, you plug in, after you jot down a relevant equation, you plug in terms of the variables given. So you say, all right, begins at rest. So initial velocity is 0, ends up on the ground, d final is 0. So I simplify the equation. Now, another strategy you can take is your variables that you use, label them in a way that helps you do the problem. So I'm saying, all right, on Earth, I'm going to say that that distance is, acceleration of Earth, time on Earth. And on planet X, notice that acceleration of X, time on X, I'm labeling it appropriately. And by the way, notice I use d naught for both of them because that will be the same for both of them. This will become important in a second. And then now I start plugging in terms of the problem. They say, hey, the gravity on planet X is half of Earth. So I represent that algebraically and I plug in. So plug this in here, and then now I get this simplified equation. Now, whenever you're doing a comparison, typically when you think, oh, if I'm comparing, I divide one quantity by another, right? That's like doing a similarity comparison, right? Just a comparison. It's this divided by this proportional to that. So what you need to do is, first of all, I'm going to rearrange both of these equations and get time by itself for both of them. Just some simple algebra. Again, this I'll fly through because I want to get more concepts across, and we'll give you these notes after. But so I'm going to take tx, the whole equation for tx, which is this thing, and then divide it by the whole equation for te. And so when I divide those two, again, here's where it's handy to have things plugged in well. The d naughts will cancel, the ae's will cancel, and I'll be left with square root of 4 over square root of 2, which is just square root of 2. So your final answer is square root of 2. So it'll be square root of 2 times, the time will be a square root of 2 times greater. Now, again, you might have been able to kind of like, well, there's a square root, blah, blah, blah. If you could do it that way, great. However, especially when they're asking for a derivation, I'll go over this briefly at one point, but you got to get used to how they grade for partial credit. And I will point that out because that's important too. So another thing you could do when you do the old exams on the College Board, look up their partial credit, learn how they grade it. And unfortunately, it's pretty inconsistent. Sometimes, like I've seen problems that would be worth 6 points on one year, another year I look at pretty much the same problem, it's worth 2 points, and it makes no sense. It's inconsistent, but it's the way it is. So just get used to over answering everything. Okay, this next one again comes from my book specifically. This is a very tough derivation. It is not beyond what the AP exam would ask you. And in fact, this setup here was inspired by something I saw on the College Board's website. I just turned it into my own question. So absorb this for about a minute, and then I will explain some stuff. Let's say 2 minutes. I'll give it till 4:42. And then we'll talk about what's it like to derive an equation on the AP exam. Okay, this one's tough. Now, whenever they ask you to derive an equation, the way I put it is you want the variable of interest on one side and all the other listed variables on the other side. Makes sense. And notice, and any physical constants as appropriate. So if you do a derivation and it has a quantity in there that is not one of the listed quantities, you will not get full credit. So for instance, let's say, and let me just kind of show you my process of derivation for this. So I always say step one is understand the situation. Like, okay, I need angular acceleration, trying to solve for angular acceleration. And I got this crazy system going on. I got this thing up here is going to be rotated. This thing up here is going to be rotated by virtue of this mass pulling down, right? And it's going to pull down with a force mg, but the tension upwards is preventing that from happening. And remember, that tension there is the same as this tension here. Does this make sense? And again, they will love to kind of combine multiple worlds. Here I have a torque problem in addition to a Atwood's machine problem. So a little tricky. Now that I've kind of understood the situation a bit, now I kind of play the game of, all right, let's start to jot equations down that are relevant. And I know that torque is, and this one I'll just do with you all, I alpha. Torque is equal to I alpha, right? It's moment of inertia times alpha. Torque is also equal to force perpendicular times distance. This is my way of doing it. It's the perpendicular force that torques the thing. Sometimes you just see it force times distance, but I write it like this. Now, these are the same equation. They're both equal to torque, so you could set those equal to one another. And you could say, all right, well, I alpha is equal to force perpendicular times distance. And I'll just simplify it to force times distance for now. And so you'd say, okay, I'm starting to get there, right? I got alpha. I need to get an equation with alpha in it, but here's the problem. I could solve this thing right now, and I have force times distance over I. Well, here's the problem. I don't have anything they want. I got force, which is not supposed to be there. So again, whenever you do a derivation, if you have anything that isn't any of the listed variables, it will be marked wrong. But I do want to be clear one other thing. Some of the listed variables may not be used. So you can't use a variable other than the ones listed, but some of the listed variables may or may not be used. Be careful about that. That is always true. And I've done every single AP exam since 1999. So believe me, I know what their trends are. So let me skip down this a little bit more. So again, first of all, we'd set those equal. Now, we set up one of those free body diagrams for the big mass. Now, remember, net force is equal to mass times acceleration. And so my way of doing this, folks, is maybe it's not so clear. And again, I know this is a lot this is crunch time, but I'm just trying to do my best to communicate as much as I can. So net force is equal to mass times acceleration. So the way I always do this is I say, pick a direction that's positive. I'm going to call downward positive because that's going to make my life easier with signs. So, okay, what's acting in the positive direction? Mass times gravity. What's acting against us? F of t. And you set that equal to ma. Notice I used big M right away because I'm talking about the big mass there. Rearrange and solve for ft. So mg minus ma equals ft. So now this is cool. Look, I got something for ft. I can plug that in for this. So now, look, I've made my life a little bit simpler. I've got a thing in terms of m. Hooray, I've got A in there. I've got alpha in there, but I still got I in here and D in here. Those are not permitted to be in our final derivation. So if you were doing this on your own, you'd be like, okay, I'm there a little bit, but you're not done yet. You're not done until you have no variables remaining that are not allowed. So, but now let's examine this distance variable, right? Well, distance is torque. It's torque. It's the distance to, distance in terms of torque is the distance to the pivot. Well, what axis are we pivoting about? Well, the tension in the rope, so this is kind of a top-down view. The tension in the rope is causing this cylinder to rotate like this. And what's the distance to the pivot? Well, that's r, the radius. So now, boom, we can plug in r. We've taken care of another variable. So now we're getting there. We got rid of D. We got it in terms of R. This is good. We're getting there. But we still have this I in there. Well, this case, they give you the I. And by the way, they'll never expect you to know the moments of inertia for different objects. You don't have to know that. You just have to know how to work with the equation if they give you it. And so they say, all right, for a cylinder spun about its central axis, its I is equal to 1/2 mr squared. So now you plug that in. I is equal to 1/2 mr squared. And then you just do some algebra, r squared. The 2 is going to cross some of that r over there. So I cross this out with that, getting rid of an r on both sides, did a simple rearrangement. And here's my final equation for alpha. So again, what's more important is this was probably very fast to follow. Get used to the themes. All right, Will first understood the problem. That was most important. Then after the understanding, I jotted down relevant equations. And then I checked myself at some points. I'm like, all right, I made some progress. As I see more variables that they list appear, I'm headed in the right direction. But I need to get rid of any superfluous variables. So I was attacking D and I and trying to get rid of those. This is so common in derivations. And the last exam, the 2021 exam, had 3 derivations on it, if you do it. The first one in particular, problem 1, was pretty brutal. That took me a moment. I'm like, wait, what? Huh. It's clever. It's a clever one. It's a good physics problem. Okay. Next one. I like this problem. This one hopefully won't give you a little bit of a break if that last one melted you. So I'll pause. Ask away if you need. Ask anything at all. So I'm going to do this in two phases, all right? I'm going to do the angular acceleration first because I think that's a little bit easier. When you are doing, I don't care if it's an experiment. If you're doing an experiment problem, a derivation, a graph, always ask yourself, is there an equation that guides this problem? Or can you derive one? If there is, use that to guide your understanding. So here's what I mean. We have, let's look at the angular acceleration first. So earlier, what I said was, you could set I alpha equal to force times distance, right? So we could just say that alpha is equal to force times distance over I. And remember, I plugged in terms of all those variables, but I'm just going to leave it like this for now. That's a bit simpler to deal with. Okay. All right. I'll finish up this one. Thank you, Francis. So any event, here's my point. Remember when we started, you have a mass pulling this thing down, causing this thing to unravel. So what will happen, and give me just 2 minutes and I'll finish this up. So initially, because you have a constant force pulling the thing down, that's going to unravel it. That's going to have a constant acceleration. And then the rope disengages, and then the acceleration drops to 0. And what that means in terms of the angular velocity is that because it's a constant acceleration, it's going to increase at a linear rate. And then the second the rope detaches, it's going to continue with a constant velocity. And that's it. It looks like that's about all we have time for. Any quick questions I could knock out in a minute or two? Something in general about the exam, etc.
William, I think everyone just wants to give you a huge thank you. Everyone, give William a big thank you. Everyone, look at how amazing he was, right? All the way from California. Isn't that so cool? I want to do something
send you
really
the notes,
cool.
by the way, too.
Oh, definitely. Thank you. Thank you so much, everyone. Let's give William a big thank you, okay? William, this is so much appreciated. And something I love to do to end the webinar is let's give William a thank you. Let's actually say thank you to William. So I'm going to ask everyone to unmute. So everyone, we're going to count to 3 and we're going to say
Xavier, I'll address you in a second. Go on.
We're going to say thank you to William. Xavier, you can email me because I have another Zoom, so I'm a little tight with time, guys. Okay. Queller's a busy bee. You know that. I don't relax. You guys totally know that. All right. So William, we're going to count to 3. We're going to all say thank you. Are you ready? 1, 2, 3.
Thank you.
All right. You're welcome.
Thank you for doing California. Thank you. Wait, everyone who wants to see William's cool shirt. William, we want to see your shirt.
Elon Musk. It's Elon Musk on Joe Rogan's shirt. All right.
You are so funny. Well, it's good to be a child. Always am a child at heart, guys, but I'm actually turning 40. Who wants to say bye to the doggy? Say bye to Goldie.
And we'll get you these notes too, by the way, Xavier. These questions are from my book. And so you could find them there, but we'll give you these specific ones in the notes after. I'll make sure to send them to Francis.
Everyone, don't forget. Okay, we're gonna go. Thank you, everyone. Thank you, everybody, for being in the Zoom, for being here. Okay, I'm gonna go. Bye, Goldie.
Okay.
Bye, Goldie.
Okay.
All right.
I'm gonna end it. Okay. Bye, everyone. Thank you. Bye, Goldie. Bye. Say bye.
And Xavier, we got you. These will be in a PDF. Okay. We got you.
Okay.
Okay, everyone. Thanks, guys. Thanks for being in the meeting. Bye.
I'm not sure. Is this just going to be left open? If it is, I don't know if it'll be here. Xavier, I'm still screen sharing, but So I will export these to a PDF for you. So these two in particular, this question and this question are from my book. The other things, your primary points of focus, if you have time to only do one exam, it should be the 2021 exam. And oh, he already left, and then you should do the 2015 through 2019 exams next. And all right, that's about it. Anything else anybody could shoot quick? I don't know if I'm going to get booted. I have no idea what's going to happen. I'm just in this room. But anybody have any? You could text me it. You could say it out loud. I don't care. No? All righty. Okay. Thank you all. Oh, do you have? All right. Thank you. The 2021, it should be right on the College Board. So if you Google, go to the College Board, just go collegeboard.com, or even simpler, just Google 2021 AP Physics 1 exam. And then it should take you right to it. And then you can download the PDF. And I'll show you that real quick too. Here. Yeah, the FRQ. They do not make available here, I'll show you. They do not make available the multiple choice, but they do. So here, like I said, every single exam I have here, but I'll just show you it. And again, this is easily a thing you could download from the College Board website. So this is what the 2021 exam is like. Again, this derivation in particular is rather tough. So the first one is a derivation. And then Ronnie, I'll give you a quick answer to your study plan. But well, here I can kind of do both at once. Do old exams. Just do old exams. My book is there. The answers are up there too. My book is there is meant to be a supplement. If you don't find the explanations on the College Board adequate, that's what my book's there for. And again, you don't necessarily need it, but if you find it helpful, great. So look, first one was a derivation. And this one's tough, and it's got components, which is not something they typically ask. So that was out of left field. And then part B is like, well, how to interpretation. Part C is a graphing thing. Then do an experiment problem. Oh, and I think I got to go at that. So, all righty. All right, Francis, I'll take off. But anyway, there it is again, just Google AP Physics 1 on the College Board, and you could find it there. And then they will have at least a 2015. And this will be in the packet that the 2015 to 2019 exam is part of the packet that Francis sent out. And yeah, that's about it. Okay, talk to y'all.
Thank you. Thanks, William. Okay. Hi,
Bye-bye.
everyone.